of quadratics. So the first thing you're going to need to do is you're going to need to grab a piece of paper, or if you're in class with me, I'll hand you a piece of paper, and also have some that are already folded, but you're going to want to have the paper sideways, not skyscraper, like hamburger style, and you're going to fold these two sides in, and they don't need to be perfect or anything, because mine definitely is not. You're going to fold it like that, and then you're going to fold it in half this way, and then open it, and then flip it over and fold it in half that way. So now you should have like 4 quadrants, and each of the 4 quadrants are going to have a different topic on it. So the first one is going to be y equals x squared, or vertex form explained. Then this bottom one is going to be f of x equals a x minus h squared plus k, which is vertex form, and then a is going to be underlined, and we're going to be looking at dilation in this quadrant. And then over here we're going to have f of x is equal to well, it's going to be vertex form equation again, but this time h will be underlined, and we will title this horizontal movement, or movement of the x-axis, or excuse me, on the x-axis, and then rewrite vertex form once again, because you do need to have this memorized. Underline k, and this will say vertical movement. So now you're going to need scissors, or there should be some in the classroom, and we're going to just cut along the line so that we have some flaps that we can open and close and just focus on one thing at a time. So our first focus is this vertex form explained and y equals x squared. So we briefly went over vertex form before, but basically in vertex form, once again, you have f of x is equal to a x minus h squared plus k. Excuse me, that looks wrong, that's a 2. So the h comma k is the vertex. So when we have the equation f of x is equal to x squared, this equation still applies. It's just that the equation is f of x equals 1, which is our dilation factor. We'll talk about that like further in the video. X minus 0 squared plus 0. So that then simplifies to our x squared, which we know is a parabola. So as you guys know, when we're finding points for this, first we want to find the vertex. And we can find the vertex by doing h comma k. So h is 0, k is 0, so it's 0, 0. Let me quickly draw a graph. 0, 0 is our vertex. We'll make that our first point. Then on either side we'll have -1 and 1, 2, and -2. And we know that the output for 1 and -1 will be the same, and 2 and -2 will be the same. So when we plug in 1, we get 1, and when we plug in 2, we get 2 squared is 4. So we know that this is 1 and this is 4. We can plot this, and this is going to be a very quick sketch. But we've also learned that the general pattern for a quadratic function for y equals x squared is over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, and it just keeps going up. So then it'd be over 1, up 9, and it just keeps going like that. So we want to keep that in mind, because I want you guys to think about this towards the end of the lesson. But that's how we graph the first one. So what happens when we change 1? A in the first one is 1. What happens when A becomes 2? So our equation is f of x is equal to 2x squared. We're going to do 2 examples in this one. So f of x equals 2x squared. To make f of x equal 0, we still plug 0 in. So we're still going to use the same values that we used the first time. We're going to use 0, 1, and 2, and -1 and -2 as well. But again, I already know that those outputs will be the same as 1 and 2. So when I plug in 0, I still get 0. But when I plug in 1, I get 1 squared is 1 times 2 is 2. And when I plug in 2, I technically get 2 cubed because 2 squared is 4 times 2 is 8. So I know that was some quick math, but when we look, this, oops, that goes there. Our graph looks like this. So our graph is vertically dilated. Our graph looks skinnier than before. So when we have when A is greater than 1, the graph becomes skinnier. That's the main thing to pull out of that. Then what happens when A is between 0 and 1? So we could do 1/2. Because when A is negative, the graph is just going to reflect over the x-axis, and the parabola is going to just be upside down. Like when we have negative x squared, the graph, if we just have our graph here, it's gonna look like that. It's just gonna be, I know that's not a very good drawing, but it's just gonna be reflected. Like this is x squared, this is negative x squared. So that's all that happens when A is negative. But what about when A is between 0 and 1? So we have our input and our output. We're still going to use 0, 1, and 2. When we plug in 0, we get 0. When we plug in 1, we get 1/2, because we get 1 squared is 1 times 1/2 is 1/2. And we plug in 2, we get 2 squared is 4 times 1/2 is 2. So this graph is going to look like this. And again, I know I'm graphing quickly, but you can slow the video down if needed. And this is going to be wider. So when A is between 0 and 1, the graph becomes wider. So now that we've looked at dilation, we can look at horizontal movement when H is involved. So if we have our tables over here in our equation, f of x, we can say is equal to x minus 3 squared. Okay, so we said that our vertex is equal to h comma k. The k in this scenario is plus 0, right? Because there is no plus on the outside of these parentheses. So our vertex, and this sometimes trips up students because there's a negative in front of this, but our vertex is 3, 0, because we are just pulling this number because the vertex form is x minus h. H is positive in this scenario. So when we have a table and we have h, we have horizontal movement, we only need quadrant 1 for our graph in this one, because the vertex is right here. Obviously, eventually, this side of the parabola is going to cross the y-axis, but we won't be drawing that far into it. So we know that our middle is 3, 0, so we want to do 2, 1, 4, and 5. So let's try 4 and 5 because we know that 2 and 1 are going to output the same because the parabola is the same on both sides, as we've discussed before. 4 minus 3 is 1 squared is 1. 5 minus 3 is 2 squared is 4. So you can see this is the same pattern as our y equals x squared. Our parabola is just shifted over 3. So if you can really understand how this formula works, you don't even need to make the table every time. You can just shift the graph yourself. But for our purposes, we're going to be using the table just so we can understand the math behind it a little bit better. So what if we have f of x is equal to x plus 3 squared? And again, that plus 0 is still technically there, and a is technically 1 in this case. We have x and we have f of x. Our h, comma k, our vertex, is negative 3, 0. Because in vertex form, it's x minus h, but there's this positive in front, and we know that a double negative makes a positive, which means that h must be negative. If this confuses you, we'll probably talk about this more in class because this can trip some students up, and practice is really what you need to understand this topic. So negative 3, 0's in the middle. We have negative 2, negative 1, negative 5, negative 4, negative 5. When we plug in negative 2 plus 3 is 1, squared is 1. Negative 1 plus 3 is 2, squared is 4. So again, it's the same. This time we're in this quadrant right here, 2 over 3. And it's the same way that we graph y equals x squared. It's just shifted to the left 3. That's all that h does, is it moves it across the x-axis. So our last quadrant down here is looking at vertical movement. So if we do f of x is equal to x squared plus 3, our h comma k, our h is 0, and our k is 3. So we know we have 0, 3. We can do the numbers that we normally do. Negative 1, negative 2, 1, and 2. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7. So obviously these numbers changed, but the pattern stayed the same. Up 1, over 1, up 1, over 1, up 3. And then it'd be over 1, up 5. So we can graph this, and all it does is it moved it up 3. And that is simply it. So again, you don't even need to make this table every single time. Let's look at f of x is equal to x squared minus 3. F of x, we have 0. Oh, our vertex is 0, comma negative 3, because k in the vertex form is positive, it's plus k. So when there's a negative sign in front of k, it's negative, which can be confusing again just because h, when there's a plus sign in front of h, the actual value of h is negative. But again, practice is really all you can do to understand that. So there's our numbers again, same numbers we used before. When we plug in 1, we get negative 2. And when we plug in 2, we get 1. So when I graph this, it's going to start below the x-axis, down 3, up 1 over 1, up 1 over 3, and you can see it just got shifted down 3. So this pattern is very useful, very helpful when you're trying to graph transformations. So to tie this all together, in the equation, f of x is equal to a x minus h squared plus k. The vertex is h comma k. And you're going to use that information to determine what values you should plug in to your table. Okay, so this is an example I want you guys to try that ties it all together. I'm going to do it too, but you could pause the video and try to graph this example. I know this ties everything together, so if you are completely lost, I will walk you through it, but go ahead and try to pause the video and try and solve it. Okay, so how I would start doing this is I would set the inside equal to 0. Well, first of all, I know that the vertex is 2, 3 for my vertex equation, and a is equal to 2. So this graph I know is going to be skinny or vertically dilated. Then what I would do is I would set this equal to 0 and get x equals 2. When x equals 2, this inside equals 0. So you know what? Scratch that. You actually do not need to do that, because we can just use the numbers surrounding 2, right? That's what we've always done. I don't know why I started doing that. So the numbers surrounding 2 are 1 and 0 and 3 and 4. Oh my goodness. Okay, so if I plug in 3, I get 3 minus 2 is 1, squared is 1, times 2 is 2, plus 3 is 5. That makes sense because I have a dilation factor of 2. 1 times 2 is 2. When I have 4, I do 4 minus 2 is 2, squared is 4, times 2 is 8, plus 3 is 11. You can always plug that number in and solve it out if you can't do that math in your head. So when we graph this, we're going to get over 2, up 3, and then we're going to have up 2 over 1 on both sides. Whoops. And then we're going to have up 6 over 1. So I want you guys to notice the pattern here, that this increased by 2, this increased by 6. Normally, right, this increases by 1, this increases by 3. So when we have this dilation factor, this 1 and 3 just gets multiplied by the dilation factor. And maybe that isn't something that makes sense, but that's something I want you guys to think about. There will be more practice problems related to this topic, but I hope that